Section 4.1 is solving systems of linear equations with two variables. So we're given two equations and we're trying to find an x and a y value. So that's an ordered pair, and that's the ordered pair that works in both equations. So if you plug in the x and the y value into both equations, they need to work in both of them. And this ordered pair represents the intersection point. Of the two lines. So we're actually going to look at three different methods for finding this intersection point. We're going to use our graphing calculator to find the intersection point. We're going to use the substitution method, which is an algebraic method, and then the elimination, or sometimes it's called the addition method, which is another algebraic method. So the first one that we're going to look at is the graphing method. And the main calculator command here is the intersection command, because if you weren't using the calculator, you'd have to graph these by hand. And if you've ever done this before, where you graph the two lines by hand and try to find the intersection point, well, I'm not very good at it, and my intersection point never looked like it was supposed to, and I could never get it right. But the calculator can solve it for you, so that's kind of nice. Now, there are some exceptions. So it's possible for there not to be an intersection point. It's also possible for there to be infinitely many intersection points. So the most common case is just that there's one. But if the lines are parallel, then they're never going to cross. They're never going to intersect. So if there's no intersection point, then there's no solution. It's also possible for the lines to be graphed on top of each other. So it's like if you graph it once and then graph another one that actually turns out to be the same one, if they're on top of each other, then it's going to be infinitely many solutions because they're the same line. Okay, so if we go to number 1, it says solve each system of equations using the graphing method. So if you go to your graphing calculator, to the y equals menu, if your equations are already solved for y like they are here, then you should be good. So if you just go to the y equals menu, and I have some pictures of my calculator which I've done before, so now I'm just kind of talking over it. So the y equals menu was right here, and you should type in your equations here under y1 and y2. And then if you press, we want to graph this on the negative 10 to 10, negative 10 to 10 window. So I press zoom and it takes me to this menu here. And you want to do zoom standard, number 6. And that's going to give you the negative 10 to 10, negative 10 to 10 window that we're looking for. So if you graph those, you'll see that those are our two lines. And we want to find the intersection point. So to do that, you want to press second and then the trace button or the calc button, and that's going to get you to a lot of different commands. So you'll see that we have value, 0, minimum, maximum, and we want to do number 5, which is the intersection command. So if you press enter, it's going to take you to the screen, and it's going to ask you a series of questions. Essentially, if you just want to press enter a bunch of times, you can. So it's going to ask you to clarify what your first curve is. That means like what's the first line that you are using. So you can just press enter. Then it'll ask for the second one, so it's asking you to declare what's your second line, and it's the top one. So you can just press enter. And then it's asking for a guess. You don't need to make a good guess. You can just press enter. And the values that are showing up here in the bottom could be different than the ones that you have. But once you press enter this last time, it should take you to the intersection point. And that should be the same for everybody. So your intersection point is the point right here, and that's 2, negative 1. So if I go back to my problem, and if I draw this, it's at 2, negative 1. And as long as your lines are close, that's okay. I know this is going to intersect at 1 and at 5 just because of the y-intercepts. So if I draw the line, I can try to make it look a little bit better. But as long as your intersection point is graphed correctly, that's the important thing. So that is the point 2, -1.